Hello, this is Jack Jackson. We're back again with some more derivative interpretation problems that we're going to look at. So I'm going to have you stop the video as we go along and see if you can work these out yourself. By the way, some of these basic derivative interpretation problems we did, these are some similar to them back in our earlier unit as well, when we first started talking about derivatives. But let's go through these now. Suppose that C of R is the total cost of paying off a car loan borrowed at an annual interest rate of R%. Assume that the number of payments and the principal are fixed. What are the units of C prime of R? Okay, as I come to each question, I'm not going to say pause, but I'd like you to pause it, pause the video, answer the question, and then press play to keep going. Okay? So just do that for every single question as we come to it. Well, in general, the units of C prime of R will be the units of C divided by the units of R. Well, we're paying off a car loan. If we're in the United States, that's going to be in dollars. And then R is in percent per year. So it's dollars per percent. Or dollars per percent. Yeah, dollars per percent. What's the sign of C prime of R, and how do you know? Again, pause if you need to. Okay, now remember, when we ask about the sign of the derivative, we're asking about the direction of the original function. So we're really asking, is the function C increasing, decreasing, or constant? Well, think about what happens. You're always going to increase the input. So if we increase the percentage rate, what happens to the total amount of money you're going to pay? Well, it's going up. So increasing the interest rate increases the total amount you pay. So C of R is an increasing function, therefore C prime of R is positive. What's the practical meaning? Ooh, here we go. What's the practical meaning of C prime of R? Okay, so if we put this in context, the units can help us. Dollars per percent. So it says if we're increasing by, if we increase the percentage a little bit, it's how much we're increasing the rate. So if we increase the rate, it's approximately at least the amount that we increase the total we pay on the car by increasing the percentage rate by 1%. It's actually the instantaneous rate of change, but that's approximately what it is. Okay, let's try another one. This is kind of related, but a little bit different situation. Suppose that M of N is the monthly payment of paying off a car loan, where N is the number of monthly payments. Assume that the interest rate and the principal are fixed. Principal is the amount that you borrow. See if you can answer this. What are the units of M prime of N? Okay. The units of M prime of N should be the units of M divided by the units of N. M is the monthly payment, so that's dollars. And the car loan is N is the number of months or number of payments. So it'll be dollars per month. How many months that you're going to finance for? Or if you'd rather say it, dollar per number of payments. What's the sign of M prime of N, and how do you know? Well, again, if we're talking about the sign of a derivative, we're asking about whether the original function is increasing, decreasing, or constant. So increase the input, see what happens to the output. In the context of this problem, if we increase the number of monthly payments, but we spread the payments out over more time, keeping the interest rate and the principal fixed, we will actually lower our monthly payment. So M of N is a decreasing function, and therefore M prime of N is negative. What's the practical meaning of M prime of N? Well, it's the instantaneous rate of change in M with respect to N, or it's approximately the amount your monthly payment, it's going to be negative, so how much your monthly payment goes down if you finance it for one more month. You add one more month to the payment plan. This is approximately, the derivative is then approximately the amount of decrease in that. Okay, here's one more dealing with a car loan. Suppose C of N is the total cost, not the monthly payment, but the total cost of paying off a car loan, where N is the number of monthly payments. Again, assume the interest rate and the principal are fixed. What are the units of C prime of N? That will be the units of C over units of N. C is the total cost, so that's dollars. N is the number of payments or the number of months. So it's dollars per number of payments or dollars per month. What's the sign of C prime of N? How do you know? Well, what happens to the total amount you end up paying for the car if you spread it over more time? Even though the monthly payment goes down, you have more payments. The more payments more than makes up for the fact that the payments are a little bit smaller each month. So in fact, the total amount you pay on the car is more the more months that you finance it off over. Pay the least if you could just go pay cash and not pay any interest. And then, assuming the principal and interest rate are fixed, you pay the least totally if you paid off in fewer months. But of course, your monthly payment is bigger that way. So you have to balance what you can do there. What's the practical meaning of C prime of N? Well, it's the rate of increase in total amount paid as you increase the number of payments, or it's approximately the additional amount you pay totally for the car, including the interest and the principal, as you increase the number of payments by one. So if you add 1 month to the additional month to the payment plan, this will be the additional amount that you're going to add to the total amount you pay for the car. Okay. So let's let P of T represent the price of a share of stock of a corporation at time T. From what I tell you here in this statement, what can you say about P prime and P double prime? So the first situation is the price of the stock is rising faster and faster. What does that tell us about the derivative and the second derivative? Well, if the price of the stock is rising, the price function is increasing. Therefore, the derivative is positive. So the derivative is positive. Of course, the price function is positive because you have to pay a positive amount of money for the stock. But the price of the stock is rising faster and faster. So it's rising a certain rate, and then the rate is increasing as well. So that means P prime is increasing, so P double prime is positive, and the original P is concave up. Now, erase the A part, and a new scenario. So we're still talking about price of stocks, but this time, instead of what we said before, this time the price of the stock is close to bottoming out. New scenario. What does that mean? Well, if the price of the stock is close to bottoming out, you're actually decreasing at the moment, almost approaching a local minimum. So that means that the graph is, and it's going to bottom out, it's going to turn around and come back up. So the graph is concave up and decreasing. So P prime is negative and P double prime is positive. But even though P prime is negative, it's almost zero because we're almost bottoming out. So it's real close to zero, but slightly negative. And then but the original graph is concave up, so P double prime is positive. Okay, we'll do some more in the next video.